Hello, my name is Solomon Ayashola, and I am an MSc Robotics student at MDX University with student number M00881460. I'm here again to make a presentation of the submission of an assessment that we were given in our robot manipulation course. This assessment is the second part of an assessment that we were given previously. In the previous assessment, we were required to draw the following letters MDX using the ABB robot, and we were able to generate the coordinate of the MDX and also able to trace out the following outline of the letters on our plane, which is our working object. For the second assessment, we were given the SolidWorks model of MDX, and we're required to trace it out using the AutoPath function to generate the targets and the path automatically without having to do all the whole calculation to get the coordinate. And to do that, of course, I have my robot and I have my pen tool, and this is my model. And after using the AutoPath tool of the Robot Studio, I was able to generate the following path: the frame, the letter M, the letter D, and the path of the letter X were automatically generated for me. And these are the targets visible. This target here were automatically generated, while this ones here were manually inputted from the first assessment. And so I'm going to go to my code, and in my code, in the main procedure of my code, of course, we assume that the targets are not moving. We assume that the work object is not moving and is fixed to a particular position. And that is why all our targets are constant over here. And when you look at my main procedure, you see that I use the TP-write function to request for data or for an input from the user. And the user will feed us any of these inputs, any of these four inputs, to determine the approach in which the robot is going to draw the letters, either the manual approach or the automatic approach, or a mix of both of them. So I'm going to play a simulation first, showing again the display of the first assessment, which is the manual approach. And just as it was in the first assessment, you see that when the robot is retracing and approaching the work object, I trace out the tip of the robot rather than the tip of the pen, just to give us a clear diagram of how it all looks like. And now I'm going to we have our flex pendants, where we're going to choose for the second approach, which is the automatic approach. And in the automatic approach, see that we were able to clearly trace out the model using the AutoPath function, and we're able to trace out the tip of the pen, the movement of the tip of the pens clearly. And I'm going to draw another simulation that is going to do the both approach one after the other consecutively. And we see that in a workplace, we may decide to want to do two jobs at a time in order to reduce wait time, such that when the robot, is done with the first work object, is done with the first piece, the robot can move to start drawing the second piece while we replace the sheet for the first piece. So this approach will reduce wait time and make sure that we complete a lot of jobs within a shorter period of time. And to make things a bit more interesting, I'm going to try to demonstrate how a pick and place robot works. Yeah, by running both of them simultaneously, in which the robot first draws the frame for the manual approach and then goes on to draw the frame for the automatic approach, and then goes back to draw the path, yeah, to trace the path of M, and then goes back to trace the path of M for the automatic approach also, and on until it is done. So this just basically demonstrates how a pick and place robot works, where it picks objects from a particular position and drops them in another position. And so I've been able to demonstrate how the showing possibility of tracing out um, a path of an object given the solid works file or the card file, and tracing it out um, to form the path and the target of of the work object. This is the end of my presentation. Thank you for listening.